Okay, now we're going to talk about friction. We're going to define it and identify frictional forces. We're going to explain the factors that determine the amount of friction between two surfaces. And then we're going to determine the frictional force and the coefficient of friction between two surfaces. Now, the reason friction occurs is because the molecules are pushing against each other. Now, kinetic friction is friction against something that's already moving, and static friction is the friction you have to overcome to get something moving. Static friction is always greater. What happens is, and you can see it from the picture, when things sit down into each other, they get to the lowest spots. In order to get them moving microscopically, I've got to get to the top of those low spots. So therefore it takes a little bit extra force to get something moving than to keep it moving. Now, the amount of force depends upon two things. Number one, the two surfaces that are in contact. That's given by the letter mu. And then the normal force acting on the object, or the weight of the object. But again, once we get to angles, it gets a little more complicated. Excuse me. The coefficient of friction is simply a ratio of the frictional force and the normal force, and these are experimentally determined. Notice how in each case the static friction is greater than the kinetic friction. And again, the easiest way to remember that is friction is fun. So choosing mu, sled sliding down a snowy hill, well, you're going to look for wood or polyurethane on ice. A desk at rest, when you want to move, you're going to have to look at what the desk is made out of and what the floor is made out of. Car with tires rolling freely, and then cars skidding. You look at both materials when you do it. The brakes are applied, causing the rubber cars of the tire to slide on the surface. The tires encounter the greatest force of friction to stop the car. Well, the greatest force of friction would be the greatest coefficient of friction. And since it's sliding, we're looking at kinetic friction, so there's your winner. Dry concrete. The diagram shows a block sliding down an inclined plane at an angle. As the angle increases, the mu kinetic between the two surfaces will increase, decrease, or stay the same. Now, this is kind of a tricky one. Because what happens is, as you increase the angle, the force down the plane, which is the force of friction, will increase, but the normal force also changes. So both change, so therefore it actually stays the same. When we do inclined planes, this will become a little more obvious. Now, to calculate the force of friction again, we're going to use the force of friction is equal to mu times the normal force. When we combine that with Newton's second law in free body diagrams, we can solve problems. The diagram below shows a 4 kilogram object being accelerated at 10 meters per second squared on a rough flat surface. If the applied force is 50 newtons, what is the magnitude of the frictional force? So again, free body diagram first. This time I drew it for you. 50 newtons to the right, it's accelerating to the right. The frictional force goes to the left. Now, you could also put on the weight and the normal force, but you know, since it's a flat surface, those are equal to each other. I'm going to say to the right is positive. The sum of the forces equal m times a. So 50 newtons minus the force of friction is equal to m times a. So 50 newtons minus force of friction is equal to 4 kilograms times a, which is 10 meters per second squared. So therefore the force of friction is equal to 50 minus 40. The force of friction is equal to 10 newtons. So in other words, 40 newtons of the force is just simply being used to counteract friction. A horizontal force of 8 newtons is used to pull a 20 newton box moving to the right along a horizontal wood surface, and the kinetic mu is equal to 0.3. So we want to find the frictional force, the net force, the mass, and the acceleration. You don't have to do them in the correct order. Matter of fact, one of them you can do real easily. Now, free body diagram. We have normal force going down, Fg going up, and we have friction force going back to the left. I'm going to predict that the 8 newtons is winning over the frictional force. I'm making that guess. So To find the force of friction, it's mu times the normal force. Well, mu is 0.3. They gave that thus. The normal force is 20 newtons. Since it's flat, the normal force is equal to the weight. So I have 6 newtons of frictional force. Now, to find the net force, I'm going to say the net force is equal to the sum of the forces is equal to 8 newtons minus 6 newtons. So the net force is 2 newtons. Now, C is one that you don't need anything else to do. You want to know the mass of the object. Well, if it's 20 newtons, mass is equal to Fg divided by g, so therefore it's 2 kilograms. Again, if you use 9.8, you're going to get a slightly different number than that, but not very much. Finally, I want to find the acceleration. The sum of the forces equal mass times acceleration. The sum of the forces is 2 newtons, so it's 2 newtons divided by 2 kilograms. 1 meter per second squared is the acceleration. Compared to the force needed to start sliding across a crate across a rough level floor, the force needed to keep it moving. Well, when I go to push it to start it moving, I have to get up on top of those microscopic bumps. So therefore it takes more to start it moving. So therefore it takes less to keep it moving. Cars moving at a constant velocity on a level road. Compare the magnitude of all the types of frictions to the force being put out by the engine. Keyword there is constant velocity. Constant velocity means your acceleration is equal to 0. So therefore the sum of the forces equals 0. If I draw a free body diagram, the engine force and the frictional force cancel each other out. They're equal to each other.